In this video, we are going to write out the electron configuration and draw the orbital block diagrams for the first 18 elements. And we're going to be drawing the ground state electron configurations. And remember that for an atom in its ground state, the number of protons is going to equal the number of electrons. So I have listed here the atomic numbers and the elements for the first 18 listed in the periodic table. And the electron configuration and the orbital block diagram have to contain the number of electrons in each atom, which, like I said, for an atom will equal its atomic number. So when these configurations are put together, we have to get the lowest energy configuration possible. So for hydrogen, which has one electron, it's going to have an electron configuration of 1s1, and we need to put one electron in that orbital diagram, and by convention, we typically represent the first electron as spin up. When we look at helium now, there are going to be two electrons, so they're both going to go in the 1s orbital, because remember, each orbital can hold two electrons. Okay, so the first electron is going to go spin up in the 1s orbital, and to minimize repulsion, the second one is going to go in spin down. When we go to lithium, we're going to completely fill up the 1s orbital with two electrons, and then next in energy is the 2s orbital, and we're going to put one electron in that orbital. So when we draw the orbital block diagram, in addition to filling up the 1s orbital, we also put an electron in the 2s orbital. For beryllium, our electron configuration is going to be 1s2, 2s2, for a total of 4 electrons. So the orbital diagram then would have 2 electrons in each of the 1s and the 2s orbitals, and one's going to be spin up and one's going to be spin down in each of those orbitals. For boron, we need to fit 5 electrons in there. So we will fill up the 1s2 and the 2s2 orbitals, and in addition, we have to put an electron in the 2p orbital. So we have to fill in, we go 1, 2, 3, 4, 5 electrons in this orbital diagram. For element number 6, which is carbon, we need to use 6 electrons. So that's going to be 1s2, 2s2, 2p2, for a total of 6 electrons. The first two orbitals, the 1s and the 2s, are going to be filled just like they were for the other elements, but now we have to make sure we follow Hund's rule, which says that we put one electron spin up in one of the 2p orbitals and another electron spin up in that second p orbital. Okay, so the electrons are not going to pair together unless they have to. We'll get to that example in a second. So now for nitrogen, which has 7 electrons, we do 1s2, 2s2, 2p3. So we fill in the 1s and the 2s orbitals just like we did before, and then we need 3 electrons in the p orbitals, which are all going to go spin up. And that again follows Hund's rule. For oxygen, we'll do 1s2, 2s2, 2p4 for a total of 8 electrons. So we fill in the 1s and the 2s just as before. Then we have to put 4 electrons in this p orbital. So we go 1, 2, 3, 4. So now we fill up all the electrons spin up, and we have to put 1 electron spin down in that p orbital for oxygen. For fluorine, our electron configuration has to contain 9 electrons. So it's going to be 1s2, 2s2, 2p5. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9 for the 9 electrons here in the fluorine. For neon, which is our noble gas, we go 10 electrons, or 1s2, 2s2, 2p6. So we have to fill up the 1s and the 2s orbital, and now we need 6 electrons in this p block. So we go 1, 2, 3, 4, 5, 6. And notice when we fill up that p orbital, each of the individual p orbitals, the px, the py, and the pz, each contain 2 electrons for a total of 6 in that p orbital. Okay? And once we fill up those orbitals, every time we add an extra electron, it will go in to the orbital of the next highest energy. So for sodium, we have 1s2, 2s2, 2p6, which is the same electron configuration for neon, but then we need to put one more electron in there, and that's going to go in the 3s orbital, and it's going to be indicated by 3s1. So we'll completely fill the 1s and the 2s, and we'll also completely fill up the 2p, and we have 1 electron in the 3s. For magnesium, we need to add 1 more electron than sodium to give us 12. So that's going to be a 1s2, 2s2, 2p6, 3s2. So we completely fill the 1s and the 2s, completely fill the 2p, and now we're going to completely fill the 3s. In aluminum, we now need to add 1 more electron, and the next highest orbital is going to be the 3p. So we have 1s2, 2s2, 2p6, 3s2, 3p1. So we'll completely fill the 1s, the 2s, and the 2p. We'll completely fill the 3s, and we'll put 1 electron in the 3p. And as you can see, when I'm filling in these orbital diagrams, we're going to start to see a trend. Okay? And that trend is that when I go from aluminum to silicon to phosphorus to sulfur to chlorine, we're just going to add 1 more electron here in the p block. So you're going to start to see a trend until we get up to argon, which we need to put 18 electrons in. It's going to be 1s2, 2s2, 2p6, 3s2, 3p6. So we're going to completely fill the 1s, 2s, 2p, 3s, and 3p orbitals for argon. So we'll go ahead and fill those up here. Make sure we follow our appropriate rules. And this is how you would write the block diagrams for the first 18 elements. And in the next video, I will go through and write out the electron configuration and block diagrams for elements 19 through 30.